the actual cost of repairing the system once they're down. You know, I have computers which occasionally break down. The reality, however, is that they always break down at the worst times. It's when I'm using them. It is inconsiderate of my computers not to break down when I'm not using them. That's my point. That's my point. It's always at the most convenient time. When I'm using the thing, it's actually going to break down. It hardly ever breaks down when I'm not using it. Well, in fact, I've never known it to break down when I'm not using it. So it's picking on me. I'm being paranoid with my computers these days. It always is going to break down at an inconvenient time. So what you are trying to do with maintenance is to try and control that breakdown process so that you can control when the machine is going to be down and not when it has to come down because it's broken. Are you with me with this particular one? It's a maintenance schedule. You don't wait until something is broken because once it's broken, it's going to be inconvenient. It's going to be the time that the machinery chooses to break down and not what you choose to be the downtime of the machine. But there's all sorts of costs involved with those breakdowns. But you have to minimize those costs. The overall reliability of any production system can be improved by doing preventative maintenance in a time that you choose. Increasing the size of repair facilities so that you do not queue services. You know that you need to do service on a particular piece of machinery in your organization, but if you don't have the facilities to actually do something about it, then it runs with inferior machines until you can find time to do it. And you can use buffer stock between stages or provide alternative equipment. And this is what Turong Energy does, by the way. They have more generators than they need to generate power. They don't run them all at once. It's possible to run them all at once, but usually they've got one of them undergoing maintenance on a continuing basis. So each of the generators is ongoing maintenance all the time. Many organizations follow a policy of replacing a whole group or similar parts when a breakdown has occurred in a similar machine, while other individual parts are still working. If you've broken one, my car is being serviced at the moment, and I said, I think I hear, as I was driving it over to the service center, I said, I think I hear a wheel bearing that's making a funny little noise. I think. So I said, replace that wheel bearing. And the guy said to me, just that wheel bearing? I said, no, replace the other one as well. Because if one's going to go, then it's likely the other one's not far behind. So this is really what you're doing. You're saying if there's a chance of one going, then replace the others as well. Take the example of the lithium-ion batteries in Boeing 787 Dreamliners. Even though there's only about 6 incidents in the whole fleet, 6 incidents in total, the whole fleet of 787s is grounded. They say, well, we're not going to take the chance. We know that there's a problem with this. Toyota and Nissan and Honda yesterday announced a massive recall. Fortunately, they're only for cars from 2000 to 2004. And nobody has one of those cars here, do they? 2000 to 2004, except me, of course. They have to recall so many, the airbags. The airbags, the fault found in the airbags. An enormous cost of replacing those airbags. So the cost of replacing parts can be considerably cheaper than to allow the equipment to break. But in this particular one, the airbags is a safety feature. You can't allow that one to remain in there. It's a safety feature for Toyota, Nissan, and Honda, isn't it? This is the Tarong Power Station in Queensland. Requires this case of regularly implemented maintenance and replacement regimes. That's coal-fired. But what maintenance scenarios might be required for a nuclear reactor? Think about it in those terms. You need to combine some maintenance strategies. In practice, an organisation's maintenance program will be combinations of three basic approaches to the upkeep of facilities. There's preventative maintenance, which is we've just discussed. There is a condition-based maintenance, which is the inspection of the parts. You can go in there and do crack tests and whatever for equipment, or put micrometers on there to measure the wear of shafts, or various ways that engineers can actually measure how long a particular part has got to go. Or you're going to have this run to breakdown, repair after failure. Which ones would a nuclear reactor use is the question that you need to ask. Which ones? Run it to breakdown. Yeah? I don't think so. Total productive maintenance, again, this is linking what the previous topic 9. It's based on similar principles to total quality management, where the operators themselves are responsible for the maintenance, which they form part of an integrated approach to risk management. TPM involves user empowerment and support from top management. Maintenance is thus included in performance measures, so workers are not penalized for undertaking non-productive activities. If you have a machine which you are operating in a factory, and you are getting paid for how much production that you can put out in a day, then you are going to put as much out as you want, as you can. If you have to maintain that particular machine, you know that you are going to lose money because you're not going to be able to supply as many parts because it's going to be down undergoing maintenance. So if you're getting rewarded only for the amount that comes out, amount of production that comes out of that machine, you are not therefore going to be willing to shut the system down to maintain that particular machinery. This is not what TPM is about. TPM is about not penalizing people for shutting the system down and doing their own maintenance. This is really what's important. It is an empowerment system. And again, the third level of modern quality assurance, remember, first one is modern quality management, consists of three things. No, customer satisfaction. Prevention rather than inspection. And the last one, I think this is an exam question as well for somebody, but I'm not quite sure who it is. Management's responsibility for quality. Management's responsibility for quality. We're talking about customer satisfaction. You've got to have customer satisfaction. You've got to have prevention rather than inspection. And you've got to have management's responsibility for quality. And this is one of management's responsibility for quality for maintenance purposes. You don't set systems up which are really making people not want to maintain their own machines because they're going to lose money through production. That's what we're talking about here. The timing of equipment replacement, though it's possible to keep old machines running, new, more efficient designs and the cost of maintaining old equipment make the replacement of machines more attractive. There's an example which I won't go over at this time because we're running out of time. But deciding when to replace equipment becomes then a financial issue, which is discussed in other courses. Have I mentioned this? Any Bulgarians here? This is the case of the Bulgarian luxury hotel. I went to a conference in a place called Varna in Bulgaria. Beautiful spot. I drove up from Istanbul in a bus. Good trip as well. Recommend it. And Varna is on the Black Sea. It's a Black Sea resort. Very nice. But but Bulgaria was an ex-communist country which had certain practices and procedures that were embedded into that particular system. The story was that I got into this hotel, and it was a magnificent hotel. It looked truly magnificent. It was on the side of a cliff. You come in on the 4th floor, and you can either go down 3 or you can go up 9 stories, I think. So it was really spectacularly worked out. But there were a couple of things that weren't quite right. Like the shower. When you go into the shower, think about the last time that you went into a shower. What's the lowest point in the shower basin? The lowest point in the shower basin, what's that for? The drain. The water goes out, right? Well, so we all know this. We all know that the lowest part of the is where the water goes out. Unfortunately, the Bulgarians had probably built this one with the plans upside down, because in this particular one, the highest part of the shower basin was the drain. The highest part. So you spent 10 minutes in the shower and another 10 minutes trying to get the water out, because it never went out. You had to sort of push it up, and eventually you sort of got rid of it. So, sorry? Which design? Yeah, I'm sure that the guy just turned the plans upside down. That's all it was. It was a simple mistake. But we kept saying, and we saw these buildings, which were magnificent buildings, but nobody was ever doing any maintenance on them. Nobody was ever doing any maintenance. So we said, but what is the Bulgarian word for maintenance? And that's the question. My question I'm going to leave you guys with. What is the Bulgarian word for maintenance? Say it louder, please.
Not exist.
There is no Bulgarian word for maintenance. We are convinced that the whole concept within that country is that there is no maintenance. Because in that particular system, it was build it, use it, let it fall down, and we'll build another one. And this is not a particularly effective way of running your economy, is it not? Maintenance of buildings are actually, and that's what we're trying to do with our plants. We are trying to maintain for as long as level the life cycle of the equipment that we've got in our plants. Thank you. That concludes the content part of 305. Thank you for your attendance and inputs throughout this unit. Good luck with your assessments. I hope to see you back to complete other units in the future, but